On the morning of January 6, 2025, at around 11:15 a.m., a man named David Morrow was sitting on the balcony of his apartment, enjoying the serene views of the Pacific Ocean as he did every day. It seemed like a normal day until he noticed sparks and flames erupting on the hills of Pacific Palisades, approximately 5 miles away from his apartment. Within just an hour, the fire had grown so massive that thick smoke completely obscured the hills. Satellite imagery showed that the fire was first reported in the Palisades area, but within a few hours, it had spread to Eatonhurst, Kenneth Getty, Skirball, and even as far as San Fernando. At the time the fire broke out, winds were blowing at speeds of 100 kilometers per hour, with their direction moving inland toward the ocean. This raises an important question. If the fire initially started in the Palisades, located right by the ocean, how did it manage to spread 30 to 40 kilometers inland against the wind's direction? This wildfire has devastated a total of 38,000 acres, or 150 square kilometers of land. Over 12,000 buildings and homes have been destroyed, and more than 180,000 people have been forced to evacuate their homes. This has become the most destructive fire in Los Angeles' history, and as of the production of this video, it still hasn't been fully extinguished. All efforts to contain the blaze appear to be failing. Water bombers, each capable of dropping 45,000 liters of water at a time, are proving to be insufficient against the sheer magnitude of this fire. These massive efforts feel like mere drops in the ocean when faced with such an overwhelming inferno. Special chemicals are also being dropped using bombers, but all efforts seem futile in the face of nature's fury. California, which is already grappling with water shortages, often has empty fire hydrants due to the scarcity of water. The fire spreading across 7 different areas has further divided the firefighters and their equipment. To make matters worse, winds blowing at 70 to 100 kilometers per hour have fanned the flames, making the fire even more intense. Before uncovering the primary cause behind the Los Angeles wildfire's rapid spread, let's take a look at California's history of wildfires. Over the past 25 years, California has been a wildfire hotspot. In 2003, the Cedar Fire in San Diego County scorched 273,000 acres. It began on October 25th and was finally extinguished on November 4th, 2003. In 2017, the Tubbs Fire burned 36,000 acres, also occurring in October. Later that year, the Thomas Fire destroyed 280,000 acres. This fire started in December and wasn't fully extinguished until January. On November 8, 2018, the Camp Fire burned through 500,000 acres and took 17 days to be brought under control, ending on November 25th. Similarly, in 2020, the Glass Fire consumed 67,000 acres. It began in September and lasted for an entire month before being contained in October. If we analyze the dates of these wildfires, one notable pattern emerges. They all occurred during winter. The current Los Angeles wildfire has also ignited during the peak of winter. So, why is it that most of California's wildfires throughout history have happened in winter? The answer lies in a natural phenomenon known as the Santa Ana winds. These are warm, dry winds that blow through Southern California and Baja California, particularly during the autumn and winter months. Geographically speaking, California's eastern region is surrounded by vast deserts, including the Mojave Desert and the Great Basin, which play a significant role in this phenomenon. The heat from the sun warms the desert, increasing the air pressure in the area. On the other hand, over the ocean, the air is cooler and the pressure is lower. We learned back in 6th grade that air travels from high-pressure areas to low-pressure areas. The greater the difference in pressure, the faster the air moves. This is exactly what happens in Southern California, where the Santa Ana winds blow rapidly from the southeast deserts toward the ocean. These hot, dry winds suck up moisture from wherever they pass, leaving the entire region extremely dry during the season. Bushes and trees become completely parched, making them highly flammable. The Santa Ana winds not only turn entire forests into fuel for wildfires, but if a fire does start, accidentally or otherwise, these strong winds quickly spread the flames. Burning embers are carried far and wide, and within moments, a wildfire becomes uncontrollable. Normally, a wildfire spreads in the same direction as the wind. However, in the case of Los Angeles, the opposite happened. The fire was first spotted near Palisades, close to the ocean, but later spread inland. To understand why this occurred, we need to look at an interesting phenomenon called the mountain wave rotor. On a mountain, The side where the wind hits directly is called the windward side, while the opposite side, where the air moves away, is the leeward side. When the windward side blocks the wind, it creates a vortex effect on the leeward side. In this vortex, the air spins in circular patterns. This means that while the air moves in one direction over the top of the mountain, it moves in the opposite direction below it. In Los Angeles, this phenomenon played a major role. The Palisades, where the fire was first reported, is on the leeward side of the hills. Due to the mountain wave rotor, winds generated at the base of the hills moved in the opposite direction from the usual wind flow, spreading the fire inland. Once a wildfire grows large enough, it starts generating several unusual phenomena, some of which are nearly impossible to predict. One such phenomenon is a fire tornado. This rare and dangerous occurrence forms during intense wildfires. It resembles a tornado, but instead of carrying dust and debris, it carries flames. The immense heat generated by a wildfire instantly heats the surrounding air, causing it to rise rapidly. As the hot air moves upward, cooler air rushes in to fill the space, creating an intense updraft. This updraft produces a rotational motion, pulling in dry shrubs and vegetation around it. This further fuels the vortex, turning it into a terrifying fire tornado. A fire tornado can overpower the local wind patterns and generate its own air circulation, making its direction almost impossible to predict. However, in most cases, it tends to climb uphill along the terrain, spreading the wildfire even further. Wildfires are a harsh reality, and with climate change, their frequency is expected to increase in the coming years. These days, advanced technologies like artificial intelligence are used to predict the direction in which a wildfire might spread. This information is then relayed to firefighters, who attempt to contain the fire by spraying chemicals around its perimeter to prevent further spread. However, in Los Angeles, every time firefighters managed to control the fire in one area, the winds carried the flames to another location, making containment nearly impossible. The first recorded wildfire in U.S. history occurred in 1871 near Michigan. Known as the Peshtigo Fire, it burned 1.2 million acres and claimed 2,500 lives. From the Peshtigo Fire of 1871 to the current Los Angeles wildfire, nature continues to remind us that controlling fires remains a monumental challenge. Yet, if we try to understand nature and adapt to the realities of climate change instead of fighting against it, perhaps we can prevent future wildfires, or at least mitigate their impacts. We hope you enjoyed this video. Don't forget to like, share, and leave your heartfelt comments. Thank you so much for your support, and we'll see you in the next amazing video.